All right, hopefully we'll try to finish up this lesson today, and hopefully you'll be able to understand enough of it to do some of the homework. All right. I didn't officially assign the homework yesterday, correct? Didn't I just say try to see what you can do?
Yeah.
Is that what I said? That's what I think. I didn't even say that. I didn't say anything about homework? All right. That's all right. I'll give you some homework today. Let's review briefly what we did yesterday, okay? Not going to go into as much detail as we did, but we're just to kind of get us on the same page here.
We did symmetric with respect to the origin x-axis and y-axis, but didn't do the line y-axis.
Okay.
And then we also went over I guess.
Right, with the line, with that y equals x cubed. Yep. All right, here we go. Let's put a point on here. I don't care where the point is. Let's just put it right here. Where is that point located? 2, 4. All right, so if I told you to give me a point that is symmetric to this point with respect to the x-axis, here's the x-axis, what would you do? What point would be symmetric to this with respect to the x-axis?
-4.
You flip it. Where do you flip it? Flip it across the x-axis. That's right. Okay, which means we're going to keep the x the same. Do you remember this? So let's write this down. You probably have this in your notes. Mia, you with me? So we start off with our original point. I'll just call the original point xy. All right. I don't know how I did this yesterday, but we'll do it like this. If it's symmetric with respect to, I didn't write all that down, but if it's symmetric with the x-axis or about the x-axis, then we keep the x-axis or keep the x point the same. Excuse me. And then what do? We change the sign or the value of the y. Okay. Did you write that down somewhere? I think we kept a little list, didn't we? All right. So where would that be? I keep the x the same, but I change the y. So instead of 4, it's what? -4. So that would be, oops, that's 3. 1, 2, 3, 4, right there. So that would be symmetric with respect to the x-axis. Got it? What if I ask you with respect to the y-axis? So again, you start off with the x and y. That's our original. See, this is the one we're starting with. And you don't always have to start with the one that's positive, both positive. Okay, I could have started with any of these, but we're just going to start here. So what do I do to my x's and y's when I try to find something that's with respect to the y-axis? I keep the y the same, correct, and I change the sign of the x. Everybody see that? So on this one, you keep the x the same, you change the y. This one, you keep the y the same, and you change the x. What if I asked you with respect to the origin? Oh, by the way, I didn't do the y up here, did I? All right, so what do we do? It's -x, so it's -2, +4. -2, +4. Okay? You with me? So what did I do here? I flipped it over the x-axis to get that one. I flipped it over the y-axis to get this one. So the origin, basically, I'm doing both. I'm flipping it over the x to get here, and then I'm doing what? Flipping it over the y to get this point right here. And what would that point be? -2, -4. So what am I doing to my x and y when I find the one with respect to the origin? Change the sign of both of them. That's right. And then there it is right there. Does it make sense? All right, that's review. We did that yesterday. That's really going to help you when we start doing lines, okay? Because they're really not doing points. And if you look in the book, they don't even teach this with just the points. They go right to the lines. But I watched a couple videos on this. I saw somebody doing this with the points. I thought, that makes sense. Why doesn't the book do that? So anyway, that's why I threw that in there. So you won't really see that in the book. but I think it makes it a lot easier when we do the lines, which we're going to do today. All right. Let's talk about something we did not talk about yesterday. And what did we say we were going to do with respect to the line y equals x? So what I'm going to do is I'm going to draw the line y equals x. Do you know how to draw that line? The y-intercept is what? What is it? What is the y-intercept? It's 0, right. What's the slope? It's 1. So here's the y-intercept right there. And the slope is 1. Up 1, over 1, up 2, over 2. I could keep going. Boom. Let's go all the way to the end. It would go to there. Would you agree? And if you want to go down 1 to the left 1. No. I'm trying to teach. Goodness.
Wow, I can't believe they would do something like that. Why would they ever?
And why don't they tell us so I can prepare for it? Ugh. All right. Let's pause this. All right, so that was fun. It was cute, I got to admit. All right, here we go. What we're doing. Okay, here's the line. This blue line right here is y equals x. So let's take that. I erased all those points, but let's. What was that point 2,4? Right here. Okay, let's make that red. Okay. All right, so when we reflect, or it's symmetric about or with respect to the y equals x axis, what we do is we switch the x and the y. Okay? So this point is what? 2, 4. So watch. So instead of x, y, what are we going to switch? The y, and right, we're going to make this y, and we're going to make this x. So if this was 2, 4, what are we going to make it in order to reflect it about the line y equals x? 4, 2, that's right. So 4, 2, 1, 2, 3, 4, 1, 2. Do you see that? So that blue line is kind of like that fold. Remember I talked about folding it over the x-axis, the y-axis? So that blue line is like the place where we fold it. And if I took this, if this is a piece of paper, and I took this and I folded it over this blue line, where would it end up? It would end up right here. Does that make sense? So it's symmetric with respect to the line y equals x. Make sense? Yeah, that's not too bad. So what do? You just replace the x with a y and replace the y with an x. Just switch the x's and the y's, basically, and that's how you can tell if it's symmetric about that line. And again, we're going to do equations here in a few minutes, right? Not just points. But knowing how to do these points, I think, is really, really helpful when we do the lines, all right? One more we have. We're going to go y equals negative x. So we're going to underline these. So we're going to find the point that is symmetric with respect to the line y equals negative x. So where is y equals negative x? Yeah, it goes through the origin, but what's the slope of it? It's -1 this time, so it's going to go all the way to here and down to here. Okay? No, not taking my kids anymore.
Any 6th or 7th grade students?
Okay, see? Got lucky.
What number is their number?
So this is the line. What is that line? Y equals negative x. So let's take that point 2,4 again. Let's go back to red. Now what we're going to do, instead of just switching the x and the y's, we're going to switch the x and the y's, and we're going to negate both of them. We're going to make them both negative, all right? So if I start off with a point, whatever that point is, again, it doesn't have to be in the first quadrant to begin with, okay? But how do I find if it's symmetric to the line y equals negative x? Well, if I switch the x's and the y's and I negate both of them, so what's this going to be? What's this first one going to be? Well, just in terms of x and y. Negative y and negative x, that's right. Okay? So now, where would it be? Remember what we're trying to do. We're trying to take this and we're trying to flip it over this yellow line, right? Fold it. I'm going to take that and fold it at that yellow line, where is this point going to be located? It's going to be where? So if it was 2, 4, where is it going to be now? -4 what? -2. All right? So -4, 1, 2, 3, 4, -2. Would you agree? If I took that point and I folded this graph along that yellow line, that's where that point's going to be located now, at -2, -4. Does that make a little more sense than yesterday? Yeah, you had some time to digest it a little bit, and that's what we're going to do. Okay. Yeah, that's good. What if, let me grab this graph again. What if we add a line? Now, when you think of a line, you're probably thinking just a straight line, but the higher up we go, they're not really lines, they're curves, they're graphs, but we're going to do one with, let's do this, y equals x squared, okay? And let's put it on here. We'll do it in red since we've been graphing everything in red. Do you know how to graph that? We did this last year, didn't we? Okay, if you're not really sure, we can always go back to the surefire method of graphing. Just do a little table, put some points in here. Let's just put like -2, -1, 0, 1, 2. All right, put a -2 in for that. What do we get? 4, right? Because -2 squared is +4. Put a -1 in there. -1 squared is +1. Put a 0, which is 0. Put a 1, which is a 1, 2, 4. Okay? So if we were going to graph this, we're at 0, 0. We're at 1, 1. We're at 2, 4. We kind of did this yesterday, but we did it with a x cubed graph. Remember that? This is a little bit easier, so we'll do it with this one. And then -1, 1, -2, +4. So our graph will look something like this. It's supposed to be a little bit curvier down the bottom, but you get the idea. Okay? It is a parabola, correct. Right? We're not really trying to graph it. They're not going to say y equals x squared and graph it. That's for another lesson. It may be in this chapter. I can't remember what chapter it's in. But we will be graphing this stuff probably pretty soon, I would guess. But what we're trying to do is we are trying to see if this graph is symmetric about the x-axis, the y-axis, the origin, the line y equals x, and the line y equals -x. That's what we're trying to do. So we're not actually trying to put the points in a different spot. We just want to find out, is this symmetric about the x-axis? If I took this part right here, if it was symmetric about the x-axis, where would it be? It would actually be down here, wouldn't it? Okay? So it's not symmetric about the x-axis, just visually looking at it. Would you agree? All right? Because this is kind of split in half, this graph right here. So it's not symmetric about the x-axis. Is it symmetric about the y-axis? Yeah, this part right here, if I flipped it over, if I folded it over, yeah, it would be symmetric about the y-axis, wouldn't it? If I folded it at the x-axis, would you have any graph at all on the bottom of this? No, you wouldn't, okay? But you would. If I took this and I folded it right in half, yeah, that would match up exactly with that. And this part right here would match up exactly with that part right there. So you can kind of see visually if it's symmetric with the x-axis or the y-axis and so on. Let's do it with some numbers. So we are going to test to see if it's, oops, not y, if it's symmetric about the x-axis. So I'm going to put a question mark here. Is this, and that's what the question they're going to ask, is it symmetric with respect to or about or with the x-axis? All right? So how could we do that mathematically? Remember what we do? This is what we're starting with. If it's symmetric about the x-axis, I keep the x the same, and then I do what? I change the what? I change the y, that's right. Okay, this is a little different because it's not just a point, all right? But it's the same idea, right? The whole reason we did all those points is so we can now look at this, and hopefully it'll make a little more sense. So if I'm trying to test, this is a test, all right, to see if it's symmetric about the x-axis. You got it? So I keep the x the same and I change the y. So I would go negative y. So what I want to see is this the same as this. If it's the same, then it's symmetric. If it's not the same, then it's not symmetric. Okay. All right. So how could I change this? How can I simplify this a little bit more to make it look more like this? Well, this is y. How can I get rid of that negative? Divide by a negative or multiply by a negative. So that would give me y equals what? Negative x squared. I can't really simplify it any more than that. Is this the same as what we started with? No, it's not. So is it symmetric with respect to the x-axis? No, it's not. You follow me? All right, that's all I'm trying to do. I'm just trying to decide, is that graph, does it fold over the x-axis? No, it doesn't. We saw visually that it doesn't. Now we see mathematically that it doesn't. We good? All right. Is it symmetric with respect to the y-axis? All right, so what do? We start with the original. We keep the y the same, but what do we change? Change the value of the x, or the sign of the x. So that's the y stays the same. Now the x, instead of x squared, I'm going to write what? Negative x. Got to put it in parentheses because I'm squaring that negative x. Let's simplify that. Can't do anything to that. So what's negative x squared? What's a negative times a negative? Positive. So what's this? It's the same as just x squared, isn't it? Is this the same as what we started with? It is. So is this symmetric with respect to the y-axis? Yes, it is. See what we're doing? Just doing that little test, all right, to see if it is. What about, is that symmetric to the line y equals x? Again, what do we do with this? Do you remember what we did to see if it's symmetric to y equals x? Yeah, you just change the y and the x. So what am I going to do with this? Again, this is our original thing that we're working with. Instead of y equals, what are we going to write? X equals what? Y squared. And now let's see if this is the same as this. Let's get y by itself. How would I get y by itself? Square root. Square root both sides, put plus or minus, square root of x. Whoops. Is this the same as what we started with? No, the square root of x is not the same as x squared. So is it symmetric to the line y equals x? No, it's not. Because if the line y equals x was like this, does this thing fold over and become the same graph? No, it doesn't. Okay. And then is it symmetric? Do you think it's symmetric to the line y equals negative x? No, you don't think it probably will not be, because here's the line from here to here. Does it fold over and make the same graph? No, it doesn't. You could put the things in here. Since we just learned this today, we'll write it out. What do we want if it's symmetric to the line y equals negative x? You switch the x and the y and you make them negative. All right, so let's test it. Let's put it in here, because sometimes it will work. All right, when you switch the x's and the y's and you negate both of them, you put it into this, and it will become the same thing that what you started with. Okay, if it's symmetric to the line y equals negative x. So let's try it. So what are we going to do here? Well, we did it right here. Instead of x equals y squared, we're going to write what? Negative x equals negative y squared. Let's see if that works. That's just negative x equals, that's positive y squared. Solve for y, square root both sides. That's a real problem, isn't it? Because I can't take the square root of a negative number anyway. All right, so it's not going to work. So you would say no for this one. You would say no for this one. You would say what? Yes for this one. And you would say no for this one. And that's the kind of stuff they're going to ask you. They're going to give you equations, and you're going to have to decide, is it symmetric about those different things, okay, with respect to those different things. It's really not that hard once you get the idea. I think doing the points at the beginning was kind of nice. All right, so how do I know if it's symmetric to the x-axis? I keep the x the same and I change the sign of the y. This one, I keep the y the same, change the sign of the x. Right here, I just flip the x and the y. This one, I flip them and change the signs of the x's and y's. If you can remember those 4 things, you should be able to look at something, do a little bit of math on it, and determine if it's symmetric about those particular lines. Is that a little bit better? Oh, we didn't do the origin, did we? What about the origin? Is it symmetric about the origin? So how do I do, let's do this, the origin. How do I know if it's symmetric about the origin? Yeah, just make it negative x and negative y. All right, so here's what our original thing was. If I make this a negative y right there, if I make that a negative x, square it, so negative y would equal x squared, get rid of the negative, so y equals negative x squared. Is this the same as what we started with? No, it's not. So is it symmetric about the origin? No, it's not. Okay? You could go look at the points. You could go to the points and see, I'll tell you what, do a different color. Like this point right here, that's 1, 1. Okay? You could see if it's symmetric about the origin, what would I do? I would switch the signs of the x and the y. That would be negative 1, negative 1. But is negative 1, negative 1 part of this graph? No, it's not. So you could just look at that one little thing and say, no, it's not symmetric about the origin. Does that make sense? Or that point 2, 4. That point 2, 4. Switch them both. That would be what? Negative 2, negative 4. Is negative 2, negative 4 on my graph right here? No, because negative 2, negative 4 would be down here, wouldn't it? Okay? So that's one way that you could see. All right? If you already have the graph drawn and you know the points on the graph, you could do that. But this is a way you can do it without even looking at the graph, what we did right there. Okay, enough of that. Let's do another. We're going to do 2 examples this time. And we're not even going to graph it. Okay, I'm just going to give you some equations. And we are going to determine if it's symmetric with respect to whatever they ask. Sometimes they say, is it symmetric just with respect to the origin, and that's it. All right, that's all you got to do. All right, sometimes they say, is it symmetric with respect to the x-axis, the y-axis, y equals x or y equals negative x. Right? You just have to read the problem and see what it asks you that you're trying to find. All right, so on this particular one, this is example 1, they only ask you one thing. They just say, is it symmetric with respect to the origin? That's all they ask. All right, so here's what they do. They say f of x is equal to x to the 5th. Now, they teach this a little differently in the book than what I just did, because we've been using x's and y's. They use f of x. So they do this a little different, but what I'm going to do is I'm going to kind of make theirs into what we did. So instead of f of x, what can we always say? This would be what? Y equals, all right? Just to make it a little simpler, all right? It's the same thing. They're doing the same thing. It's just the notation is just a little bit different. So I want to see, is this symmetric with respect to the origin? Okay, instead of writing all that down, I'll just put origin. Is that all right? Okay. So how do I know if it's symmetric to the origin? I just change the signs of the x and the y. Keep them in the same order, I just change the signs. So what am I going to do here? I'm going to change the sign of the x's and the y's. So I change the sign of this y, which would be negative y. I change the sign of this x, which would make it negative x. But it's still to the 5th power, isn't it? I want to see if this is the same as that. All right? I got to simplify it a little bit. At first, it doesn't look the same, does it? Because I got all these negatives in there. But let's simplify it and let's see if it really is. All right? So, can't really simplify that. What about this? Anything to the 5th power. If I have a negative to any odd power, what's that always going to give me? Negative. So that's the same as negative x to the 5th. Would you agree? Yeah. Now, what can we do? I can get rid of this negative. Multiply both sides by a negative. That gives us positive y. Multiply this side by a negative. That gives us positive x to the 5th. Now, is this the same thing as what we started with? Yes, it is. So, is this particular graph, got to think of all the words again, symmetric with respect to the origin? Yes, it is. All right, so I say yes. You getting the hang of this? Yeah? Okay, let's do another one. That was part A. Let's do part B. We'll just move it down. This one's looks a little more confusing. Now they put g of x, but again, we can just replace g of x with what? With y, correct. All right, so here we go. Let's do this one. Everybody watching? So instead of g of x, we can just say y equals x over 1 minus x. Again, we are checking, we're doing a test to see if it's symmetric to the origin, okay, with respect to the origin. So that means I'm going to change my what? My signs of the x and the y. Keep them in the same order, but I'm just going to change the signs. So let's do it. Let's change the sign of this. That'd be negative y. Let's change the sign of that. That's a negative x. And then I got to change the sign of this x. So it's 1 minus what? Negative x. See why I put the two negatives there? Because I had to change the sign of this. I guess we could put it in parentheses. Let's simplify it, and let's see if it actually simplifies to our original. All right? So I can't really do anything with that, but I can do something over here. So this is going to be negative x over, what's that? 1 plus x. All right? But I still got a negative out in front of the y, so what I'm going to do is I'm going to multiply everything by a negative 1. So that'll give me, I'll tell you what, let's move it over here. That'll give me a y. If I multiply this by a negative 1, what does that give me? It gives me a positive x over 1 plus x. Now again, we don't multiply the top and the bottom, because if I did that, I'd be multiplying by a positive, wouldn't I? All right, so I just multiply the top by a negative. That gives me this. Now, we check. Is this the same thing that we started with? No, it's definitely not. This is y equals x over 1 plus x. This is x over 1 minus x. They are not the same. So is this particular graph symmetric to the origin? No, it's not. And so we say no. Okay? All right. I don't know if you guys being quiet is good because y'all understand it, it's too easy for you, or bad. You're just looking at it and you're like, I have no idea what he's talking about. It's hard to read you. Let's do one more. Yeah, we probably only have time for this. I got a few little things I got to finish up. But I think after we do this next example, I think that's enough to be able to do most of the homework, if not all the homework, all right, on the assignment. So this is example 2. Here's the graph that they give you. And you don't even have to graph it, okay? You don't have to, graph the thing, at least not yet, okay? But you could put it into Desmos, you can put it in graphing calculator, see what it looks like, but we're going to do it mathematically, and we are going to see if this is symmetric about all 5 of those things. Okay, symmetric about the origin, the x-axis, y-axis, the line y equals x, and the line y equals negative x. So we're going to do all 5 of them, okay? So let's do the x-axis first. Is this symmetric about the x-axis? If I folded it on the x-axis, would they match up? I don't know what that graph looks like. I have no idea, all right, but I can do it mathematically. So if it's symmetric about the x-axis, I keep the x the same, and what do I change? I change the y. So I would go x times negative y equals negative 2. So does this equal this? It's supposed to be negative 2. Well, this would be what? Negative xy equals negative 2. Let's get rid of this negative right here. So I multiply both sides by a negative, so xy is equal to what? Positive 2. Is this the same as what we started with? No, it's not. So, is it symmetric with respect to the x-axis? No. And that's your answer. It's getting pretty easy now, isn't it? All right, what do you think we'll do next? The y-axis. All right, so this time we keep the y the same. What do we change? We change the x. Don't you think that's going to come out to the same thing? Yeah. Equals -2. This is negative xy. It's the same thing as what happened before. So I'd get xy is equal to +2. So no, it is not symmetric. Now, let's do this one. Let's do the origin. Since we did the x and the y, let's do the origin. So what do we do with that? We change the signs of the x and the y. So I'm going to go -x, -y, and let's see if this becomes our original equation. Okay, if it's the same as the original, then it's symmetric. If it's not, like these two, then it's not symmetric. Negative times negative is positive. That was an easy one. Xy equals -2. Is this the same as this? Yes. So is it symmetric to the origin? Yes, it is. Okay. And let's write it down. Is it symmetric to, this is D, to y equals x? What do we do if we try to find if it's symmetric to y equals x? We just switch the x and the y. Is that going to make any difference here? No, xy and yx is the same thing, so is it symmetric to the line y equals x? Yes, it is. Okay, is it symmetric to the line y equals -x? Well, what are we going to do? We're going to switch them and change the signs of both of them. So technically, we're doing this. But pretty quick, you should be able to see that that's going to be the same as xy, isn't it? Negative times negative is positive. Y times x is the same as x times y. Is that the same as this? Yes, it is. So, yes, it's symmetric to the line y equals -x. If I had time, which we don't, I would put it on Desmos. I'd put this graph on Desmos, take a look at it, and see. Does it flip over the x-axis? No. Does it flip over the y-axis? No. But it does flip over the x and the y together to the origin. And it also flips along the y equals x line, and it also flips along the y equals -x line. Without even looking at the graph, we can figure that out. So your homework is whatever I sign that first day. Let's see. Because I have 2 assignments. We're kind of behind a day now already. 14 to 20. Okay? I probably should assign them all, but I'll just do 14 to 20. Okay, so 14 to 20 is your assignments. And I'll probably let you work in class on the assignment tomorrow because I've pretty much taught everything. There's a couple things I haven't gone over, but I don't even think they ask you those things on the homework, so it doesn't make much of a difference.